Okay, so we are live. I think. Hi, hello everyone. Please let us know if you can see us and hear us. Okay, we have 18 people. Oh, nice. We can see chat from LinkedIn as well. Hi, hello. Okay, so maybe we can wait 1 more minute or maybe less. Okay, so maybe we can slowly start so everyone can join us in the meantime. So yeah, I'm pleased to welcome you to the next edition of Functional World. It's 7-1, so I'm super excited. And apparently 7 is a lucky number, so Łukasz, you will be lucky today, I think. Yeah, and today, thanks to Łukasz, you will have the opportunity to hear more about OpenTelemetry and its applications based on Scala's Mesmer project. So yeah, if you will have any questions to the presentation, like during the meeting, you can ask them directly in the chat. So I think Łukasz will answer all of them right after his presentation. And also, if you will have any additional comments or questions or something to Łukasz, you will have all contact details provided in the chat. And also, we are still looking for speakers. So I will be super excited to do something together, organize something together. So my contact details will be provided in the chat as well. And well, I think that's it from my side. So Łukasz, if you are ready, I think we can start.
Yes, I'm ready. Hello, everyone. Nice to be here. My name is Łukasz Gajowy. I'm a Scala developer in Scala. And as Matylda said, I'm going to tell you about monitoring Scala applications with Mesmer and OpenTelemetry. So this presentation consists of basically two major parts. The first one is the OpenTelemetry introduction to OpenTelemetry, because there are some important aspects that you need to know before actually learning what Mesmer is. But while you get to know them today, in the next 30 minutes, you will be quite easily able to guess what Mesmer does. At least that is my hope. So without further ado, let's go and let's tell you about OpenTelemetry. And let's start with an example. So it's a generic example, some sort of a, I don't know, microservice backend application connecting to some front end and the other way around. So we have the particular pieces in our application. So we have a front end that is quite possibly written in JavaScript. And then there's the backend application, two instances of it written in Java. This is called the service A. But at some point, we decided to rewrite some functionality to Scala. So that's the service B. Maybe we're trying, to modernize something. Maybe we're trying to write something new. That's not important. What is important from the point of view of this presentation is the fact that we now have three different languages: JavaScript, Java, and Scala. And since, let's say, our system needs to run some machine learning processing, then we are probably using Python. So there's the fourth language that we need to be fluent on to actually have the whole functionality covered. So that's our backend application. And if you'd like to get to know some more details about that, then you would probably ask the following questions. I mean, the details about its operation. So first, the most important probably question from the business perspective is whether our product is always available, and if not always, how much downtime do we have? Super crucial thing, especially in commercial application. But then you could ask more, and ask a question: how many HTTP requests does your, for example, the Java services handle per minute, and whether it's better or worse than the Scala server that we just developed quite recently, right? So that's also an important one. Going even deeper when it comes to execution times and time in general, how long do our SQL queries take? Again, is the Scala backend faster than the Java when it comes to SQL? Maybe we need to investigate something in the Scala backend, or maybe in the Java backend based on that metric. And then, since this is a big application and it probably sends multiple requests from the front end, what are the particular steps that the requests take? Do they go straight to the Java application and then to the Python application to collect some data and then get it back to the front end? Or do they only go to the Java application and do not reach the service C, which is written in Python, because probably for some requests that's not needed. And there's also the matter of multiple instances. Which instances were actually reached when we were fulfilling a request? That's also something important. And since we are so deep into debugging, then I guess the thing that we would probably even start with would be having logs in one place. So we need some log aggregation. And I started to answer a little bit while I was asking the questions, because I like to spoil a little bit. So we need some metrics, right, for the HTTP request throughput and rate and SQL query execution time, and that's the answer for the first and the second questions. But also there are other telemetry signals, because this is how it's called, namely traces and logs. So traces would be the information about what was the path, and logs, of course, this is quite self-explanatory, but this is also called a telemetry signal. This is why I very badly wanted to have it as an answer to those questions. So okay, so right now we have our answers. We know what precisely we want to do when it comes to collecting the telemetry data, but we don't know how to do it yet, right? So basically, that's how the data transport would look like in a general sense. So we would get all that telemetry data, all the metrics, all the traces and the logs, and we would get all the data, telemetry data, and send it to particular storages of different kind. So for metrics, we would have time series databases, for tracing something different, and for logs, we would probably have some, I don't know, document-based databases that would collect the logs. But the important thing is that right now you have different storages for metrics and for tracing and for logs. And that doesn't necessarily stop there, because you sometimes even want to have multiple storages per the same signal type. For example, for metrics, you would like to have Prometheus, but maybe for some other metrics, you would like to have some sophisticated systems that can even predict what the value will be or whatnot. There's lots of fancy stuff right now in the market when it comes to that. But so when you want to do that, when you want to send the telemetry data, you get all sorts of problems, especially in such a complex system that is built with multiple languages and multiple services. First problem would be that you have per signal, API, and SDK. So say you're collecting metrics and you're collecting them from the JavaScript frontend. Then you collect them from a Java backend, from the Scala backend, and from the Python, I don't know, AWS Lambda jobs that run the predictions for you. And so there's multiple languages, multiple APIs. They probably look different. Same goes for signals, right? So I was talking about per language APIs and SDKs, but there's also the same case for the signals. So you have different APIs for metrics, different APIs for traces, and different APIs for logs. Normally, when you use, for example, Prometheus and Zipkin for tracing. Those are two distinct APIs and they don't know of each other's existence. So that's also a problem. The third thing would be vendor lock-in. So every time you use Prometheus API, the Prometheus API, the native one, then you need to stick with it. And if you want to, I don't know, migrate your metrics to some other system, then it's not so easy. You probably need to rewrite that code. And remember that you support 4 languages, so 4 applications need have some heavy refactorings. So you're locked in. Another aspects such as configuration. So different types of configurations. Again, the same story goes here because whenever you configure Prometheus API, you probably do it in a different way than you would do it for the Zipkin API or for the logging storage. And how do you correlate particular signals? So by correlation, I mean how do you attach, for example, some metrics to how do you correlate some metrics with logs, so that you know that at a particular point in time you had a spike in HTTP request throughput, and you could find the logs that are telling what is exactly happening. So when you have multiple APIs that don't know about each other, that's a problem, and you can't really. Sorry, there's a question. So we can create telemetry events independent of platform. Just wait a little bit because right now I'm talking about multiple different APIs. Where was I? So how do we correlate? Well, we need to write some custom code. We need to put some additional effort to do that. When it comes to communication, there's also a problem of sending all that data, because when you send data for 3 different signals, so metrics, traces, and logs, there's actually probably a significant load of data. So do you want to send that data directly, or do you want to send that data through some middleman that would probably patch the data or could be scaled and offload the traffic in your private network? And there are more and more problems that you would need to solve using 3 different APIs. So you would probably like to have some mitigation of those problems, and the mitigation comes with OpenTelemetry. OpenTelemetry is a standard specification, standard set of APIs and SDKs that serve the purpose of that work for traces, logs, and metrics. And by saying standard specification, I mean that there indeed is a standard repository with standard written in Markdown documents that you can see, that describes how metrics should be collected, how traces should be collected, and how logs should be collected. And all the SDKs and APIs are written according to that standard. So it's not like you have different conventions everywhere. The goal is to have everything as similar as possible. So that's one mitigation when it comes to multiple languages, right? The other mitigation is that it gives you a set of it doesn't stop on the APIs and SDKs. It gives you also standard configuration and sensible defaults. So everything is configured again the same way, at least in the languages. The traces, the metrics, and the logs are configured the same way. And this is, in my opinion, also very important. There are sensible defaults when it comes to the configuration. So oftentimes it's as easy as just setting up the OpenTelemetry tools, and you don't even need to configure a lot. Probably some periodic metric fetching, and that's it. There's also a set of standard exporters, and there's the collector. And those are, in my opinion, really important tools when it comes to actually managing the traffic. So exporters are the pieces that you attach to your applications that can use either the native protocols. So for example, the Prometheus protocol to send data directly to Prometheus, or they can use OpenTelemetry protocol, so-called OTLP protocol, that can then send data to the collector, and the collector can do some post-processing of that data so that, for example, batch the data so that we do not send 1 minute worth of data, but 5 minutes worth of data to the backends that store the telemetry data. So this is also a very important bit, and allows of handling the telemetry data in the standard way, because collector understands all the signals and can batch all the signals as well. So in a standard way. And this is something that I think I said. So the telemetry backends, the places where you store the metrics, the traces, and the logs, can communicate with the collector and the exporters either directly or indirectly. So that's also really nice. And that's how it would look like when it comes to attaching that to our application. This is just like to highlight what I just said. So every application right now in our backend would need to have the OpenTelemetry exporter added. And when we collect the metrics, we would use the OpenTelemetry API and SDK to add the code responsible for collecting the metrics. And then after that, the exporters, when we run our application, the exporter part will periodically, or in some different manner, but most of the time periodically, collect the metric values, the traces values, the logs, and send it over with some kind of a protocol. So in this case, this is the OpenTelemetry protocol, but it could be the native one and go directly to the backends for storage. But I wanted to show you that you can also use the OpenTelemetry protocol and go through the collector. The collector is an application. You can start it using a Docker Compose. You can start it using Docker and scale it. This way you can offload the traffic. And the most important part is that the collector knows the platform specific protocols, and this is why it is able to send something that the metric backends, the tracing backends, the log backends understand and can digest. So this is really cool. And this is how the code looks like when it comes to collecting the metrics. This is some Scala code, I guess. And the only thing that you need to do to collect your metric is that you need to create an instrument. In this case, this is the count fancy feature usage instrument, the value. And every time you want to collect the metric, you just increment it, and that's it. Everything else can be even automatically configured by OpenTelemetry standard configuration mechanisms. And in this case, our metric means that we are counting how many times my feature that I implemented was used. But I also want to be able to tell how many times it was used per organization. Let's say we have a backend that serves some purpose for multiple organizations, and I'm doing that by adding attributes to next to the values that I'm reporting using the instrument, and this way I get this data counted for all the instrumentations separately. This is, by the way, called labels in Prometheus, if you're familiar. Sorry, I said that that's the only thing. It's not. You also have to, add the dependencies of OpenTelemetry. One interesting bit here is that I'm adding the OpenTelemetry SDK extension autoconfigure. This is the thing that will take care of the automatical configuration for you. And the code sample below for Docker, where it says Docker Compose App, is the place where I'm actually starting the OpenTelemetry collector image, just for the sake of this demo, and the Prometheus instance just to collect the metrics. And when I start my application that has the code to attach the that has the metric collections code that I just showed you. In Prometheus, after some time, I will see the metrics being collected. And I even can see the distinction between the organizations, thanks to the fact that I use the attributes. So that's basically it when it comes to OpenTelemetry and its manual instrumentation. So because I'm saying manual because we did that manually. But what if I don't want to write any code at all? What if I just want to, start the metrics and forget about it when it comes to, adding them? Well, I, can use automatical instrumentation for that purpose. And the difference is that automatical instrumentation, which is also a feature of OpenTelemetry that is supported by some of the API, some of the languages I know of auto instrumentation in Python and in Java. So the thing with auto instrumentation is that it is able to attach the code automatically to your libraries in your that are used in your backend application. And in Java, it is done using the OpenTelemetry Java agent. Java agent is the special, agent. The Java agents are a feature of Java itself. It's not OpenTelemetry feature. But it's a special agent, Java agent for OpenTelemetry that detects what libraries are used on your class path and modifies the libraries with the code that attaches the metrics, traces, collection, so that in runtime you've got your library code, the same code that it used to be, but enriched with the metrics collection and trace collection. This is all done using ByteBuddy. If you're familiar, that's a library for bytecode modification. And you can read a lot more about instrumentation under the links that are there. I'm going to share that presentation later. And the only thing that you need to do when you're using automatical instrumentation is that you need to specify the Java agent parameter when running your application and pass the OpenTelemetry agent. And of course, you need to add your application, your example application that you want to instrument with the metrics. And what will happen during the startup of the application, you will get is that you will see lots of instrumentations being loaded, and that means that metrics and traces collection is being installed right now. And when you do that, when you start your application this way, and of course set up the collector and the Prometheus or the traces or Jaeger in case of traces, you will see the traces being collected for some libraries out of the box. For example, here in this case, I'm showing you that the Akka HTTP library has traces collection instrumentation added, has been provided with the traces collection instrumentation, and the same goes for JDBC library that was used underneath. And thanks to that, we can see a trace what happens with my requests that cause some kind of an SQL queries, and how much time did they take in each part. So the JDBC, so the SQL query took 12 seconds, and the whole request took about 23 milliseconds, sorry. But the traces are not all that the auto instrumentation give you. You also get metrics, as I said, and in this case, I'm showing you the JVM memory usage metric that was instrumented for you by the Java agent. So this is even better. Right now, you don't need to write the instrumentation code. So you don't need to add any code related to metrics or traces. It just gets added for you automatically by OpenTelemetry. I say that you don't need to add the manual instrumentation code, but you still, of course, can use manual and automatic instrumentation at the same time. They are not exclusive. You can use them together. And that's all pretty cool, but there's one thing that always bothers me in such cases. Can I, have automatical instrumentation for my own libraries? That's probably the question that bothers you as well. Or do I need to rely only on the instrumentations that are provided by the OpenTelemetry project? So in other words, if my library that I use isn't supported by OpenTelemetry, do I still stand a chance of having the automatical instrumentation? And the answer, of course, is yes, because I wouldn't make such a long, introduction if the answer was simply no, right? So to actually instrument your own libraries, you can use OpenTelemetry agent extensions. And they're not as hard as you would expect. It's just a matter of writing your own separate jar that implements an instrumentation module. And since this is a service provider interface, you need to make it detectable. So hence this is so this is why there's this auto service annotation at the top, and it has to have a name, and you have to provide a list of type instrumentations. So this is essentially the place that a list of instrumentations that first detect the library on the class path and say how the library code has to be modified. To see how it's done, just take a look at Advice API of ByteBuddy. It's pretty simple when it comes to doing some basic stuff. Of course, more complex stuff is not so simple, but that's the general idea. We're using ByteBuddy to modify the bytecode, and we're passing a list of ByteBuddy transformations here. And when we do that, the only thing that's different when it comes to running the auto instrumentation from the previous example is that we add our own extension in a parameter. So my OpenTelemetry extension jar is the extension, example jar is the application, and the Java agent stays the same. And what happens at the beginning, when the application is getting spawned, is that our extension code is getting detected by the OpenTelemetry Java agent, and it's ready to be used. And the bytecode manipulations are being attached to the application the same way as it was for the libraries supported by OpenTelemetry. There's a question by Imran. Is that extension straightforward for Scala, or is it only for Java annotation? Wait a second. So this extension can be used not only for Java, it can be used for Scala, and that's instrumentation extension. So we mean that is it only Java, or is it? I mean, I guess the answer to that question, I'm not sure if that's what you mean, is that you can use that extension for not only Java but for any JVM language. Because the Java platform supports Java agents, so you are able to use the Java agent for any JVM language. Okay, so coming back to the presentation, that's how you run the extensions. And so right now we have the extension, we have the automatical instrumentation, we know how to write extensions. So what we did in Scala was that we created the OpenTelemetry extension for Scala libraries. So what we are essentially doing is that we have a set of type instrumentations, the so-called instrumentation modules, right? We have a set of them that instrument particular Scala libraries. So whenever the libraries are on the class path of your application and you use our Mesmer extension, then you will get the metrics out of the box. I'm saying metrics because right now we are focusing currently mostly on metrics, but there are plans to focus on more aspects, more on that later. And it works seamlessly together with existing OpenTelemetry instrumentations. So it's not like you have to choose something. So it's not like you have to choose our Mesmer agent over the OpenTelemetry agent. The trick is that we wrote it as an extension. So you always use the OpenTelemetry agent and the extension. And this is nice, especially because of the fact that OpenTelemetry supports lots of traces, lots of standard. I don't know, for example, you saw the JDBC traces. This is what OpenTelemetry gives you out of the box. We don't need to set it up. So that's pretty great. And we currently support two multiple libraries, but two major areas. The first one is Akka, and that's new metrics for Akka. For example, for actor metrics, we have the actor created, terminated metrics, and many more. For the full list, please see the supported metrics link over here below. It's in the Mesmer repository. And we also have lots of metrics for cluster, Akka persistence, and Akka streaming. Well, Akka streaming is a little bit experimental right now. We are working on improving it now. But still, that is the case that we have some metrics for that as well. And when it comes to Zio, we took a little bit different approach. We didn't provide new metrics. We decided to we decided to add the to wrap the existing Zio metrics, because Zio has actually quite nice metrics API thanks to the great care of the Zio maintainers. And so we just wrapped the Zio gauges in OpenTelemetry gauges and Zio counters in OpenTelemetry counters. And thanks to that, every metrics that you write using Zio metrics API are getting passed to OpenTelemetry, and you can benefit from the OpenTelemetry support fully. There's also the Zio execution metrics. They, for some reason, I don't know why, were not using the Zio metrics API. They're pretty low level as well. So we decided to wrap it using our bytecode manipulations manually, but there's only 6 of them. Nevertheless, they are also supported by Mesmer. And as for examples, this is an example of an akka metric. This is akka persistence being supported, and that's persistent event average time being collected. So as you imagine, I had an example application that was sending some SQL queries, saving something, and persistent events were occurring in akka, and we registered the time. And that's an example of a Zio metric. You get those metrics when you turn on the default JVM metrics in Zio. And that's an example of the JVM thread state metric being collected by Zio and forwarded to Mesmer. But there's also a whole list of different metrics being collected this way and forwarded. Basically, any metric that you see here with the forwarded word in it is forwarded from Zio. There's another question from Imran. Thanks, Imran, for all the questions. Is Zio metrics using Java agent also? In that case, would there be 2 Java agent if we use OpenTelemetry? So it uses the Java agent. It uses the OpenTelemetry Java agent. It's not some kind of a Mesmer Java agent. It's the OpenTelemetry one. We just add the Mesmer extension to that agent, and thanks to that, you only have one agent that uses our extension, but it's still one agent. You don't start 2 agents, and so there's no chance of any collision, I guess, between the agents. Yeah. I hope that answers your question, Imran. So coming back, we have some plans for the project. It's still in a very early state, but we are getting some more momentum in it. We just need to simplify the code base a little bit because it actually was significantly rebuilt some time ago. We used to have our own agent, but we deprecated it, and what you saw today is the current architecture. So it is the OpenTelemetry agent extension now, which is better for us. We have less code, but still we need to simplify the code base a little bit. Then we will probably focus more on Zio. We feel that that's a better direction. Actually, we are not sure yet, but that was our idea, our current idea. And we would also like to instrument more Scala libraries, like we did for Akka and Zio. So we've proven it very actually quite simple and quite doable. So why not, support more libraries? If you have any suggestions, the feedback is very welcome on what libraries could be supported this way. We are thinking about some libraries like some HTTP libraries, for example. I don't know, STTP probably. And tracing is the big topic that I personally would like to bite really hard, because tracing the same easy way we were able to add support for metrics, we could do for traces. So it's a shame we don't have them yet. We should have them for Scala libraries as well, so that you could see lovely traces for Scala thanks to Mesmer. And that was it. That was my presentation. Thank you for your attention. And if you have any more questions, I'm still there.
Thank you, Łukasz. I think you have one more question from LinkedIn. It's on the beginning. Can we integrate with Databricks?
The question is whether Databricks supports OpenTelemetry. If that is the case, then I would say yes. Because what we use what we do essentially in our extension is that we use OpenTelemetry API and SDK, and that's the only thing we do. So it's the question whether OpenTelemetry supports, if Databricks supports OpenTelemetry.
Okay, guys, do you have more questions to Łukasz? Yes, it is one more question.
You mean the one from Domingo, right?
Yeah.
So do Scala database drivers currently support OpenTelemetry? Actually, it's not like they need to support anything. It's whether there are utilities that will wrap the code of the libraries and add OpenTelemetry metrics collection there. And what it's actually, but you mean the drivers, okay? So I don't think the drivers have any embedded support for the OpenTelemetry. Maybe I misunderstood the question, but I don't think that there is some support.
Okay, guys. Anyone? Okay. Okay, guys, so you have contact details provided in the chat to Łukasz. So if you will have any more questions after the meeting, you can ask Łukasz directly. And well, thank you very much for your time, for the presentation. And well, see you next time.
Thank you. Bye.
Okay, we have one more question.
Is it easy to migrate Common to OpenTelemetry? I've seen what Common does with OpenTelemetry. I think they have OpenTelemetry. I've seen that Common has its own agent. It's quite a different approach that we took. We want to build telemetry support with OpenTelemetry and using only OpenTelemetry tools and using the OpenTelemetry Java agent. I don't think Common does that. So but at the same time, I know that they have some OpenTelemetry support, but don't ask me. I am not the Common. I'm not a Common guy, so yeah.
Okay, we have some delays, so that's why
Yeah, probably.
the comment was delayed. Okay. So it's cool. So I think now we can say goodbye. So thank you once again for the meeting and see you next time. Bye.
Thank you. Bye.